Alright, so we have NET-200 10, 19, 16. This was a Wednesday, and this is like day, I don't know, it's like day 15. Not sure. We finished up chapter 5 today, so we started out about the OSI model. again. So here we have an application is connected, or application layer is like a hook. Sometimes people refer to it into an app. All these applications we run that have communications to a network. We prepare the data, presentation layer, prepare it, and we set up a session, sometimes referred to as a peer-to-peer, and then we're going to segment the data and get it ready to transport it. And we have a couple different ways of transporting, which we'll mention in a minute. So we segment the data. Now we're going to find the best path, add IP addressing, and get the best path. So we go from a segment to a packet, we encapsulate it, and then how to get it from one specific place to another. So that's the link, the data link. We also then create what we call a frame. And in a lot of cases, if it's Ethernet, then we add the media access control. We have the logical link control, which is software linking in. Then we have the data link control. That is where we actually control the data linked. We're going to get it between two locations, and the physical layer is going to actually send the bits, figure out how to send them across. Okay, so we finished up chapter 5 today and took the exam. And I'm going to run through a few more things that we reviewed. Here we go. Application hooked in up here. You know, this could be a web server sending the HTML back. And presentation, was it encrypted? Was it an HTTPS secured? Encrypted the data? How is the data being formed? So now we have a chunk of data. Either it's HTML, let's say, coming back from a web page, or it could be an email, it could be a URL link going to, eventually going to go to a web page, but we have this data. So I'm going to circle that right here. Here sits the data, and eventually you'll notice that data is in here and it gets encapsulated. So we set up a session. Now we figure out how we're going to transport it. UDP, that would be like streaming, no checking, or TCP. We're going to check and make sure the information gets there. If it doesn't, we're going to resend it. The session's not going to end until we take care of it for UDP. For TCP. We're going to make sure it gets there. For UDP, we're just going to send them. Like a streaming video would be an example. Alright, so now this data, if it's too big, like it's a big HTML file, we'll split it into segments. Okay, so here's a segment, however many we need, we'll split it all up into those segments and then send each one of those segments down to the network layer, in which we're going to put on an IP address. And the IP address is going to help us pick the best path. And then here we call it a packet. So down here at the network layer, it grabs all of the information from the segments. So that would not only have the data, but it'll have the port numbers in there too. Then it's going to add source and destination IP addresses. And we call it a packet. And then all of this comes down in here. We have a packet. We have IP addressing, the actual data, and now we're going to make what we refer to as a frame using Ethernet. That's what we're talking about now, Ethernet, which is extremely popular. So logical link control is the software that connects us up. This data link control going down and where we actually put on a MAC address or the physical address to get it. Once it goes on to the cable, you get it from here to wherever we're going. Get the bits there. So then that information is added on, so we encapsulate that. Cyclic redundancy check could be put in there. If we're doing store and forward, we can check and make sure that the packet hasn't been damaged. And then we have MAC addresses, source and destination MAC addresses in there. And then you can look up the specifics of what is in a frame. And how are we going to send that? Well, we can do what I mentioned, store and forward. Store the whole frame, cyclic redundancy check that to see if there are any errors. If there are, we drop the frame. Okay, that makes more sense later on. Cut through, we can just look at that destination address. Once we see it, we can start forwarding it out of port. When we look at a destination MAC address, that'll tell us which port in the device to send it out of. So, for example, in a switch, when there's a PC here, this port right here has this PC's MAC address. So when information comes into the switch, it sees that MAC address, sends it to that PC. Alright. Now, since we work with primarily IP addresses, like we ping and IP addresses are used to move information through the internet and so forth, we need to build a relationship somewhere in these lower layers of the network, like if we're using Ethernet, between the MAC address, the physical address that will actually get it to the device. That'll actually get it to the device, and the logical address, the one that we use to find a device or a web server or whatever. So we build a relationship, and we use address resolution protocol. Let me use another color for that. Address resolution protocol. We do an ARP, and the ARP matches up IP addresses with MAC addresses. It does it in our PCs, it does it in routers. Two places for right now that we need to keep track of that. So when, well, we'll show an example of that, but I could show it right here. When this information leaves and heads on out, and let's say goes to the internet, and when it comes back, there's going to be some routing device that's going to know the IP address, and it's going to assign the MAC address so that when it hits the switch, it goes to the correct PC. Alright, talk about Ethernet, 802.3. and Wi-Fi 802.11. These two are probably the most popular way to connect at the data link layer. Data link layer. So if we were to look at an example here, this would be like in our labs. We've got PCs in the room. The switch remembers their MAC address. When a PC leaves, and let's say it goes out to the internet, traffic goes up here. How does it know not to go to another device here? Well, we have an IP address. We have an IP address of something, let's say out on the internet. Okay? Now you may say, no, we got a URL. Well, URL and domain name services eventually get us back to where we have an IP address that's going to work through the internet one way or another. So when this computer looks for a device, or it's got an IP address, and the IP address isn't here, then it uses a default gateway. I'm going to explain that more in a little bit in the router. When a router doesn't see it, then it uses its default gateway. When this router doesn't know where it is, uses a gateway, then eventually ends up in the internet, and the routers in the internet go ahead and forward it to wherever it's going, and then it comes back. So then when it comes back, let's use brown coming back, the internet knows, because of the ISP, those addresses go here, and I'm skipping a few details, but it comes back into the router. It's that router here. When it gets to here, it knows the IP address of where it's going back to, okay? And so then this router can put a MAC address on it, so it re-encapsulates it, and then when it hits the switch, it goes back to the correct PC. Now, if we wanted to go from one PC to another, we could ping, let's say, to check to see if they're there, ping the address. Then what would happen would be an address resolution protocol. It would do an ARP, a broadcast, and would look for the MAC address of, let's say, this PC. Once it finds it, it builds the same table, and then we're able to send information right here. So when we get an IP address from out on the internet, through a URL or however we get it, when we ping it here or try to access it here, we do an ARP and we don't find it. So then we forward that to our default gateway. And then it checks, and if the router doesn't have it, it forwards out its gateway. And this router doesn't have it, forwards out its gateway. And eventually it hits the internet, where these routers know then the best path to get to there. Alright. I think that's more than enough for now. That's it. Done.